interdisciplinary engineering, how to think of projects, how to think about what to do next, potential careers in being able to do things. So I actually have three personas. Now I'm a teacher. How many of you are my students? How many of you are students? I've got a few students, yes. I taught 2,000 students last year. So I teach at Stanford University, I teach at the R42 University. Secondly, I'm an inventor. So I started working on speech recognition, started working on handwriting recognition, and then started looking at biology. And my first company was sold to Motorola, my second one was sold to BlackBerry, and the third one to Apple, the most arrogant phone company in each time. This is not the first time.
Oh, no, but back up. I may have jumped you in. Okay, sorry. Yeah, I'm sorry. I had to switch presentation. Keep going.
The third persona, I'm an inventor, right? I'm still inventing things.
Yeah.
And we'll talk about a couple of those inventions that we're looking at. And to think about what you can actually do. So let's have a slide we can get going. My first AI system, I've been really working in AI system for 40 years. My first AI system was 40 years ago. And really transitioning from field to field. The first things I know, I'm an electrical engineer. I prefer bits to atoms. I'm all sort of fingers and thumbs. So great respect for mechanical engineers. And then went to Cambridge to do engineering. We just call it engineering. We just lump all the engineering subjects in one subject. And then went to MIT to do management science. It's financial engineering, neural networks for stock market. And then went to Stanford. Anyone know which? Well, some of my students know which department. Anyone know which department I went to? Which was where we invented AI at Stanford. Which department was it? I know Carol. Caroline said psychology. Yes, psychology. It wasn't computer science. It wasn't electrical engineering. But we invented something called the backpropagation algorithm, which is how neural networks learn today. And when you started working on looking at speech recognition was the difficult problem of the day. Went on to handwriting recognition, looking at lots of signal processing problems, and that's where we started looking at numerous. The last 10 years I've been looking at mathematics and medicine, and this is me in 1984. Not me, it's not me, but the project I worked on was speech recognition on the first laptop. 64 words at a time only. You do only 4,000 words. This is the handwriting recognition system, cursive handwriting. So everyone else was doing one character at a time. We were doing cursive, so you don't know where one letter begins and one letter ends. Those of you electrical engineers or control system people, you can use things like dynamic programming or recurrent neural networks. We're basically doing the first convolution neural networks, but in 1991. And fit it actually in a device. And this is me 30 years ago. So proof I've been working in neural networks for 30 years. I've been working on 40 years. And by the way, I thought I was late to the field 40 years ago. The term artificial intelligence was coined in 1956 at Dartmouth. The term machine learning was coined in 1958. The first perceptron, which is the first component of a neural network, was by Rosenblatt, a neuroscientist, not an engineer. And so things are interdisciplinary. And really what I'm going to talk about, my history now, is I'm now a professor not in electrical engineering, they wouldn't let me in. Not a professor in computer science, they wouldn't let me in. Maybe Santa Clara will let me in. But in medicine. So I go from Silicon Valley to Bio Valley. And what does that mean? So we heard about the 200 billion transistors in a chip. There's 100 billion neurons in the brain. Each neuron is connected to a few thousand other neurons. So there's 100 trillion connections in your brain. The latest GPT-4, the latest GPT-5 is about 3 to 5 trillion. They don't actually tell you the number. So unlike 1983, which is, where it was 1 million times difference, we're only like 30 times difference to the complexity of the human brain. Now the only problem is we get the same wrong answer back quicker. And that's what the professor at Cambridge used to say. People always ask, what if we have more memory, more computation power, what can you actually do? They always ask us engineers, no, what can we deliver if we have more resources? And so that's the, humans versus AI. Are we actually getting closer to actual consciousness and self-awareness? And so this is where I think biology is coming in as engineers. The only existence proof of intelligence is actually us. But we don't run on silicon, with respect to my two colleagues here. We don't run on silicon. We seem to be, we run on carbon and cells. So, I think the next 10, 20 years, some of you young people might look for projects to do, is thinking about how biology merges with silicon, how it merges with semiconductors. Is it possible to have actual cells connected to semiconductors? Is it possible to have artificial organs with electronics in them? We have some of those already. But can we have some sort of self-feeding ideas? What's interesting about human cells, it fixes itself by itself. But unfortunately, the cells need to be fed. We need to give it nutrition. Whereas we turn off the battery for our laptop, it goes dead, put it on again, it's perfectly new again. That doesn't happen with biological cells. And innovation cycles are getting faster and faster and faster. Certainly we've got the internet, we've got the, we're going to about 30 years, 40 years, we've got the mobile phones, PCs, it's getting shorter and shorter and shorter. And what do we look at moonshots? How are you going to get to moonshots? There is a science of moonshots. And I didn't realize it at the time, but maybe my projects years ago were actually quite big. When I tell people I'm doing speech recognition now, I say, yeah, so what's so hard about that? But in 1983, it was quite hard. And so for things that I tell younger people or even companies, aim for big ideas and then work backwards to figure out how to solve those things. And then, as we're all engineers, figure out the smallest step to do to accomplish that and shield it from pessimism. People always say it won't work, it'll never work. In fact, when I get that response, I actually work on it more. We've got some aerospace professors here. I'm not sure if you know this, in 1903, the New York Times said it would take 10 million years of calculations to work out how to fly. This is November 1903. And in December 1903, Orville and Wilbur Wright fly. But they can only fly 100 feet. So most of you can fly 100 feet, but you're not going to fly. 20 years later, people are fighting with each other in wars with planes. And 40 years later, people are taking flights. So moonshot thinking, what am I working on? Biology. I'm working on a vaccine. A vaccine for what? Oh, it's a vaccine for aging. Wait, what does that mean? Vaccine for aging. Can we cure all diseases in our children's lifetime? This is actually from the Chan Zuckerberg Foundation. When they came up with that like 10 years ago, probably 10 years ago, I almost laughed at that, it's impossible. But now I actually think it might be possible. And with AI, we might be able to do it. We actually now have things that can actually work. We're living in an age of databases, computational power that can actually sort of break through that barrier of aging.